Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we will discuss how variable initialization has become a bit more complicated in C++. What is initialization? The process of initializing variables feels like something which should be simple to understand and use. In computer languages like Python and JavaScript, there are very few rules, and the way variables are initialized is rather straightforward. In C++, this subject can get really messy very quickly. All of the terminology is defined in the C++ standard, if you can read it and apply the rules. The examples on CPP reference can be confusing, and it takes time and effort to work through the code. It is important to remember the C++ standard is a living document which changes as definitions are refined. The information in this talk is based on our best understanding as of C++ 20, and most of the examples will only require C++ 17.
The first question developers should ask is, why should variables be initialized? In C++, accessing any variable or object which has not been properly initialized to a valid value will result in undefined behavior. That seems like a good reason to ensure every variable and object has been initialized before its value is read. Since undefined behavior must be avoided in any correct C++ program, initialization is your responsibility. Some of the objects created in a program will automatically have a valid initial value for the given data type. Some will not. As the developer, you need to know the basic rules. There are two terms which sound very similar. However, they are fundamentally different. The process of initialization occurs when a new object is declared, and as part of the declaration, the variable receives some value. This value can be something you specified, or it might be compiler generated. This is where the terms get a bit tricky. If the initialization code specifies a value, the expression which provides this value is called an initializer. There are several different ways to do initialization in C++, and most likely your code is already using several of them. The idea we want to present is that there are other forms of initialization which may improve code readability and correctness. The simplest form of initialization is called default initialization. This form occurs when you declare a variable without providing any initializer. The value for a default initialized object depends on two factors: the data type of the object and its lifetime. In this example function, all of the variables are being declared locally. Primitive types are default initialized to an unknown value. According to the C++ standard, this means var a has an indeterminate value. It might be 0, but it is more likely to be a random garbage value, which may not actually be a valid integer. Reading the value of var a or var c in this function will result in undefined behavior. If the object being declared is a class or a struct, the default constructor will be called if one exists. In our example, the default constructor for stdstring will be used to initialize var b to a valid empty string. If a variable declaration is static or has global lifetime, then the rules for default initialization change. Since var d is static, the value will be initialized to 0 at the beginning of the program, even though int is a primitive type. Another way to look at this is that var d is default initialized using 0 initialization. For var e, which has a type of stdstring, the default initialization does not change when the static keyword is added. For objects which live for the duration of the program, the behavior of default initialization will also use zero initialization, just like for static declarations.
Brace initialization is a term which is commonly used in the C++ community, since many of the modern forms of initialization can use curly braces. We felt it was of value to mention this term does not actually appear in the C++ standard. Using the phrase brace initialization is not harmful. Just be aware it does not identify one of the defined forms of initialization. We have listed the 5 forms of initialization which can use curly braces. Value initialization will almost always use curly braces, and there must be nothing inside. In the declaration, the variable will be initialized with an empty or 0 value, whatever is appropriate for the given data type. If the object being declared is a class or struct, the rules are a bit more complex. If the class has a default constructor, it will be called. However, before the default constructor executes, the data members of the object may be 0 initialized by the compiler. In our first example, var1 will be set to an integer with a value of 0. For var2, the default constructor for std string will be called, and the initial value will be an empty string. In the third example, the initial value of var3 will be a null pointer. The return statement is pretty interesting. It may not be obvious, but this line of code also uses value initialization, and 0.0 will be returned. For this line of code, you can use either parentheses or curly braces, and the result will be the same. With the other 3 examples in this function, you must use curly braces to prevent the initialization from being parsed as a function declaration. To be clear, we do not want to declare a function named var1, but rather a variable of type int. When C++ programmers talk about initialization, the most common form they think about is direct initialization. Typically, parentheses are used, and there must be 1 or more values. Curly braces can also be used. However, if there is more than 1 value supplied with curly braces, it is not actually direct initialization, but rather list initialization. We will show some examples of this a bit later on. In our first 2 examples here, the variables width and height use direct initialization, even though one uses parentheses and the other uses curly braces. For the third example, we are using direct initialization to call the constructor for std pair.
This may be obvious. However, it is worth noting there is a significant difference between copy assignment and copy initialization. These examples are all copy initialization. At first glance, they do sort of look like assignment operations. However, since the data type is specified, these are declarations. When a variable is declared and the initial value is specified using an equal sign, it is copy initialization. As a minor point, move assignment is a valid operation which was added in C++ 11. The Standards Committee did not need to add move initialization because it is unnecessary. The process of copy initialization does not actually do what we think of as a copy. There is no actual copy happening here, but rather an instantiation. Prior to C++ 17, a class like stdatomic could not be initialized using copy initialization, since it was not supported. The initializations for the variables count A and count B produce the same result in a C++17 or C++20 compiler. List initialization is one we believe adds the most benefit for developers. This form of syntax always uses curly braces. Our first three declaration examples under A all use an equal sign. Even though the variable delta is just an int, and found is simply a bool, they are each being initialized using a list containing one element. The variable word is declared with the data type of std_string, which is a class. The list initialization has an initializer of 5 character values. Since this class has a constructor which takes an initializer list, these values are received as a list, and word is assigned the value of tiger. If the std_string class did not have an initializer list constructor, the compiler would have looked for a constructor which took 5 separate char parameters. If neither of these constructors were available, it would be a compile error. Since using a list initialization is very convenient and tends to improve readability, some developers are tempted to convert all parentheses used for initialization into curly braces. We have read blogs which proclaim using list initialization everywhere is a good way to prove you are writing modern C++ code. This may be true. However, developers all need to know about the errors which can be introduced by doing a quick search and replace. In example B, we are initializing x and y, which both have the data type of std_vector. Since x uses curly braces and has more than one argument, this is list initialization. The vector x will contain 2 int elements with the values 5 and 10. However, vector y uses parentheses, so direct initialization will occur. In this example, the compiler will call the constructor, which takes 2 integer parameters. The first parameter is the count, which defines how many elements should be created. The second parameter is the value for each element. So y will contain 2 integer elements, both of which have the value 5. Clearly, using list initialization versus direct initialization for std_vector produces different results.
We have explained most of the forms of initialization available in C++ and shown the fundamental principles. However, there are more areas to cover, such as aggregate initialization, and how it interacts with list initialization. There are also some fascinating corner cases, some of which you may want to use and others which should be avoided. In a future video, we will explain more of initialization and talk about ways to reason through your code.
For more information about CopperSpice, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back in a few weeks for our next video.